Hi everyone, thank you for joining. Uh, my name is Mizan Rahman. I am CTO and co-founder of Emerge IQ, which is a data science and AI as a service organization. We've set this session up, a series of sessions called Data Science and AI for Company Dummies. It really is what it says on the tin. The intention is to really strip back and demystify what you know, data science and AI is, in as layman's terms as possible over the series of sessions. We're going to have 3 sessions. In this session, we're going to cover the bare basics of what is AI, and some of the jargon, and basically have a panel discussion of with 3 of my contacts, colleagues, to really kind of at least increase the intelligence amongst those who have joined in this area. I have been co-founder for now coming up to 2 years. Previously worked in banking sector. I was my last job was at Morgan Stanley for fixed income, and previous to that, I was at Goldman Sachs. So I've basically had nearly 20 years of working in banking, primarily in electronic solutions. So we're taking a lot of the experience that I kind of gained in that field, and myself and co-founder Tashfin Shafiq, who should be online here as well. We set up this company. I'm going to hand over to Chris, and then Hayne, Chris, and Kate to just do a brief introduction, and we'll kick off.
Okay, hello everybody. My name is Hayne Aung. I'm Chief Data Scientist at Emerge IQ. I've been with the company for a fair while now, and I've been good friends with Mizan and Tash and all the other people here. And my background is in academia, so I'm a lecturer in computer science, and I teach artificial intelligence. And my research area also is in applied machine learning. So I'll leave it at that for now.
Hi everyone. My name's Chris Bryandes. I have a small consultancy called Cognosian, which may have to change the name soon because of a little bit of a legal issue with a big company that should remain nameless for now. But I do consulting in a wide range of AI topics, really designed to add value to businesses and come up with simple solutions for people that aren't really sure how they can apply data and where they can use it to help their business. Before that, I spent about 20 years within the financial sector, covering everything from derivatives to pension risk management and technology. So I have quite a broad background there, but my interest in machine learning and AI goes back to sort of my undergrad in the last century. So I've been keeping tabs on the subject and really actively practicing it since 2008. So thanks very much.
Yeah, and hi everybody. My name is Kate Berry. I'm a data scientist here at Emerge IQ. I have an undergraduate degree in maths from the University of Sussex and a master's degree in data science from City University of London, which I completed last year. And then I came on here at Emerge IQ last summer and been there since. And I kind of work on everything data science and AI related here. So yeah, that's me.
Okay, thanks guys. Okay, so before we kind of kick off, I'll just give an outline of the agenda. The first 30 minutes, we're going to kind of have a Q&A situation. I'm going to put some questions to these guys. We were going to have some poll questions set up, but due to some technical issues, unfortunately, that's not going to happen. So hopefully in the next session, we'll be able to do that. However, we'll use the poll questions to try and drive some discussion, and later on, after the panel discussion, we can have a Q&A. If you have any questions, please just put them into the chat to everyone. And Gathoni and Hiral, who are our kind of program managers, we'll open those questions up later on to Q&A. Okay, so I guess without further ado, an introduction as to why data science and AI is important. We have come out of what was called the AI winter, and perhaps I can then go over to Hein to explain in his views what AI data science is, and also some of the jargon such as machine learning and neural networks, and then we can take it from there.
Thanks, Mizan. So I think as the first speaker, it's somewhat incumbent on me to really just tell you, or try to describe as best as possible, what AI, artificial intelligence, actually is. And as an educator, I think that describing jargon and buzzwords with other jargon and buzzwords is a bit of a cop-out. So I don't want to do that, and I want to try to describe at least the most broad term in this list of terms that you see here on this slide as the superset as AI, artificial intelligence, which has a subset of machine learning and deep learning, etc., etc. But I don't want to go into those yet. But I just want to talk about the principle of what AI actually is, and how you might want to think about it as people from industry, and how it might be useful, and how you might regard it, and why it's such a big deal nowadays. But before I do that, I want to do a bit of a walk down a bit of history a little bit, just to give a bit of context, because we talk about things like fourth revolution. Why are they called fourth revolution? So if we imagine that if you remember back in history, 150 years ago-ish, there was the Industrial Revolution. The Industrial Revolution of mechanics, steam technology, and mechanical engineering, electrical engineering, other combinations of those sorts of understandings came about. And what did that do? What did that Industrial Revolution do? But essentially, how I like to describe it, was the automation of manual labor, or the automation of physical labor, where you had a tractor instead of somebody, horse and cart, or we had some machinery instead of somebody doing things by hand. So it was automating and making more efficient manual physical labor. So of course, that transformed everything. That transformed the economy, that's transformed how companies operate. And we all understand, and we all live downstream of that now, and we all understand why that was such a big event in human history. And we all understand now why that's important. We wouldn't go back to that. So through that lens, I want to talk about artificial intelligence and more broadly computer science and data science, but I just want to sort of package it all into one term for now, and why it's important. And the way I would describe artificial intelligence is, rather than it being the automation of manual or physical labor, it is to some degree the automation of some, but not all, but some mental labor, mental tasks and work. So it's while the Industrial Revolution is the automation of physical work, the AI and computer science, computing and AI revolution, so to speak, is the automation of mental work. So for example, somebody looking at in a factory looking at a conveyor belt of objects, and rather than having a person there selecting objects to put in a bin, you could have a camera, some machinery and some algorithm that understands what to look for or how to select things and make decisions based on that. So it's a very specific sort of mental task that otherwise would have been done by a human being. So really I want to leave it at that point as to why all of this is important, and where in your lines of work, where you have people working or things that require thought process and decision making and looking and thinking, if you can boil those down into specific challenges and tasks and jobs and work tasks that might be done in an automated way using algorithms and techniques and methods in artificial intelligence, there might be a scope for using this new understanding. So that's how I would like to put it now, in terms of what AI is through the lens of industry. I won't go into further detail quite yet. I'm happy to do that later, but that's how I want to describe AI through the lens of, at least in commerce for now. I mean, obviously, as repercussions all over in other parts of in life, but that's how I would put it at this point.
Yeah, I mean that for me that kind of nails it on the head. We're in the next evolution of industrial revolution, where essentially, the automation of the human thinking and other non-physical type of behaviors can be emulated through computer science. I mean, to that point then, Chris, looking at the history of AI, I mentioned earlier the AI winter. How, in your experience and knowledge, and I had the slide showing kind of a brief history of some of the key stages in the history of AI. How do you think, where have you seen AI evolve, and where do you think it's going?
Yeah, well, the first thing to note, I guess, is
one thing, and also in the context of businesses and company dummies as well. Why is it very important?
Yeah, I mean, it's easy to get distracted by a lot of the jargon. I mean, some of the stuff that is powering the latest deep learning revolution is nothing that hasn't been around since the 50s. I mean, neural networks they're basically, at a low level, they're all sums you can do on a calculator. They were initially proposed as a way not to exactly mimic the human brain, but inspired by some of the low-level kind of neurophysiology there, using very simple methods. And the reason they've taken off lately is because we've just stacked lots of them together. We've thrown masses of data at them, and we've got loads of computing power. But I guess
just a little bit of a description on what a neural network is then.
Yeah, I mean, so basically a computer neuron is just a little node. It takes in a bunch of different numerical data you've collected, and it weights them all, sums the weighted sum together, and fires out an output, and it passes this on to other things. And really all they do is they're just black boxes. Ultimately, people used to use the term pattern recognition a lot, and what neural networks do is, imagine I have a box and it's got lots of dials, and I can tweak them all and twiddle them. I take in some inputs and I tweak the dials until for every possible input that comes in, I get some sort of output out. I can train the model on stuff I've seen. So if I'm trying to recognize, say, pictures of people's faces, I can just take an image data, put in the numbers that correspond to that into the box, and I have an algorithm to turn the dials until it correctly says, yes, that's a face, no, that's not someone's face, based on some training set, with the hope that if you give it fresh data, it'll be able to spot that. But really, it's a big, very simple mathematical operation under the hood. Yeah. And so, the research in this started in the 50s. There have been lots of comings and goings and fashions and cycles in AI, sort of every few years. And this was primarily driven by academia. People have their pet research topics. It generates a wave of interest. They all go into one domain. And so, I mean, actually, I went back to uni in 2008 to do machine learning, and there was almost no mention of neural networks in the course. It was all different types of technique. But really, I'm kind of going off on a tangent. I mean, I guess the thing here is that people have always taken data and applied techniques to it, whether it's traditional statistics or the fanciest neural networks, trying to get insights from it. So I think, people that want to do this need to actually say, well, what's my business problem? What am I trying to solve? What data do I have? What can I get? And then it will become apparent from that understanding which models are applicable. But I think I've gone off on a bit of a tangent, really. So,
well, I mean, it's like, I guess to get us back onto pieces, like, where do we see us in the future? Where is, data science and AI isn't going anywhere as far as I'm concerned.
So just quickly on that, I mean, AI used to be the term for like a proper, you see the Terminator, you see the HAL 9000 you see there's actual machines you can talk to and respond like humans.
Yeah.
Yeah, Arnie there. That's what AI used to mean. It's taken a dip in that respect. You hear the people who are really trying to push the cutting edge of this stuff talk about AGI, artificial general intelligence. You know, this is the province of the really well-funded players like Google, DeepMind, and other OpenAI companies like that. But for now, I think AI just really means how can I make sense of my data and extract some insights from it.
Okay. Okay, so then I guess moving over to Kate, you know, on that, you know, why, in your experience, and have you, you know, do you believe, you know, AI, the importance of AI? Why is it so significant? You know, and perhaps you can mention some of the projects we've been looking into as examples for companies, you know, of companies that have come to us and actually said, we've got this problem, can you help us, you know, solve it using artificial intelligence and data science?
Sure, yeah. So I think what really makes data science and AI important is just that there is such a huge volume of data in the world generally. There's more than we could ever really comprehend. And I think a lot of businesses as well, they're gathering a lot of data and they're kind of storing it, but they don't really know what to do with it or how to do it. And so data science, it kind of, it provides us with the tools so that we can kind of bridge the gap between having a lot of data, wanting to do something with it and not really knowing what to do, and being able to actually gain some kind of insight from it to process that data. And so I think data science is actually a very broad topic. It's not just AI, it's AI, machine learning. There's also kind of statistical analysis, visualization of data, handling big data. So there's all these tools available that can help you to turn kind of like the incomprehensible array of numbers into something that you can actually get some kind of insight out of, and something that you can use to make better informed kind of data-driven decisions in your business. So I think Hein kind of mentioned that AI can help to automate the things that humans do. So for example, we have a project called Fiber IQ, which is where we want to be able to automate the process of analyzing air pollution samples. So typically, traditionally, you would have a human analyst, they would take a sample and they would physically use a microscope and count the individual little fibers that are in the sample. So our idea is it sounds quite obvious really, to apply AI to this problem, because we think we know it'll be more efficient and hopefully it'll be more accurate. So that's an example of how we can kind of improve upon something that humans have been doing using AI. But I think what's also powerful about AI is that it can help you to kind of discover like the unknown unknowns in your data, is how I kind of like to think of them, as kind of you can use it to explore your data and to find the underlying patterns and the relationships that you didn't know were there and you didn't even really know to look for. So it can help you explore your data, find these kind of deeper patterns that humans are kind of like in too high of a dimension for us to even think of as humans. I think that's kind of what's so powerful about AI.
Absolutely agree. It's been quite a compelling journey for us as an organization to find these opportunities, and the companies that we're working with have come to us with very simple problems which we've not really we've kind of realized that no one on the street has really tried to tackle them. And by virtue of just having a dialogue with them and saying, well, actually, we can apply certain models, or we can write algorithms, and we'll talk about that shortly, to help automate and make more efficient that whole process. Not only is it it makes efficiencies in that organizations, it's actually it's proving to be quite profitable. And to that point, let me just share just a quick slide on some of the stats that we pick up here. 61% of companies in the next year are looking at doing major data initiatives. 40% increases in productivity. There's B2B marketing executives believe that AI will revolutionize their industry by, sorry, that's needs to be updated as of this year, but it's a hugely growing industry, and it's really something which people shouldn't really be ignoring. Okay. Some of the, so just jumping back to some of the jargon, then Kate mentioned, some of the work that we're doing, and fundamentally we run these, and Chris, you mentioned it before. We run data through models or algorithms. Perhaps Chris, you can explain, what are algorithms and data science modeling?
Yeah, I mean, an algorithm is really just a recipe that a computer can follow to solve a particular kind of problem. So, I mean, I guess the easiest way to explain is like, suppose you're looking up a word in a dictionary or an entry in the phone book. You open a page and you're looking up for Mizan, and it gets to G, and you think, well, I've got to find M. M is after G. Get that right now. You flip forward, you've overshot, you go, okay, I've got to T, go backwards to get to M, and you gradually home in on it. And that's the sort of thing you can express in computer code. So, I mean, computers, they just follow very precise instructions. They have to be precise so you get bugs, but otherwise they're pretty dumb like that. And the algorithm is just the instructions to the computer for solving a problem. What it's not, by the way, is when the government marks GCSE, gives predicted grades, and everyone was saying, oh, they used an algorithm. No, that's what I would call a formula, when they said, take how you did last year with this and this and that, and we'll predict. That's actually a formula which you might get using an algorithm. So I wanted to correct that nonsense that was commonplace in the press, but it's a recipe.
Okay, thanks for that. I've just noticed some questions coming through, so keep sending them through. We're soon going to be opening up for Q&A, and we'll kind of resolve some of the questions that do come through. I mean, to that point, when data science and AI is still a very, the expertise, the know-how, the abilities, and I guess the competencies required to be deemed a data scientist or an expert in AI. Hein, in your view, what kind of expertise and resources do you think organizations need to think about, be it whether it's in-house, or be it whether they're coming to organizations like us to facilitate on their behalf, are required to actually be competent in data science AI?
Yeah, it's a good question. Well, I mean, I think it depends on the goals of the organization, first and foremost. What are their key performance indicators? What are the things that they look for? It's not always about the bottom line, but often is as well. Regarding where a company that might not necessarily have historically been anything to do with computing, or have people work in the area of computer science and therefore by proxy artificial intelligence, one thing that companies often will have, just infrastructurally, as Kate alluded to earlier, is computers. They also have lots of employees. They have systems. They have things set up for their organization, databases, other sorts of information technology setups, networks, and things like that. So everywhere and anywhere these days, regardless of what line of work you're in, you'll have data. You'll have mounds of it, and you'll have all sorts of data setups inherently, and that's just the way the world works these days. So that's the first thing that companies will have. Now, with that data, as was alluded to earlier, I like the term unknown unknowns. You'll have data that's broadly speaking, in two forms. One is structured data. So that would be some sort of table in a spreadsheet that's got rows of names and columns of other things, and it's part of some sort of report that you're writing, and it's perfectly structured, and you understand what it is, and it's explicit. The other types of data that you will have, and you will have it, and you might not realize that it's important, is what's called unstructured data. So that's email threads and data that's sort of a pile of data, a pile of information or messages that you had over some project or some work or clients that you were working with, plus other types of information. It could even just be things like how often people go in and out of the car park or go in and out of a particular door, how often a computer is switched on, the fire alarm. So there's all sorts of data that's all over the place that you might not think is data. That is also there, but it's there, but in an unstructured, somewhat more chaotic way. So all companies will have data, and the realization and that is sort of underpins those numbers that Mizan showed earlier is that there's value in there. There's value in all of that to some degree, and some of it might even be value that one might not have realized is valuable. So how does that relate to the sort of consultancy and the sort of work that we can do in emerging IQ for people in many different companies? Is that we could help to facilitate that understanding of what you might be sitting on, what sort of capabilities you might have that you might not realize, just to begin with. Even if you come to us and say, well, I don't really know anything about it. We run our company in the way that we normally run it. I know that there's always AI stuff going on, but we don't really know, how to even start this conversation. That's fine. We can say, well, depending on what you want to divulge and disclose, we can even just have exploratory conversations and see, okay, what might manifest from some of the techniques that we know, some of the things that we've done in the past with other people and other clients that have helped them to reveal value in their data. And that's what it's about. And we have now enough data, because data really depends, and the very basic statistical idea that if you only have small amounts of data, it's not very useful. But if you have mounds and mounds of, what would the term these days, data lakes, big data, once you have enough of it, then there are patterns in there, there are sequences in there, there are things in there, there are trends in there that are there but need uncovering, and that's where expertise, or even if you have personnel that are that might have numerical experience and background, we could see how we can work with everybody and to help to get people to the point where you can then really learn about what you really have in your company. And the good thing is you don't necessarily need any further fancy supercomputer or anything like that. These days, things are done fairly easily in cloud computation, fairly easily in the machinery that you will already have, and in the technology that you're probably already sitting on. So that's really how I would sort of characterize the current situation. Yeah. And going forward, it's going to get more, it's going to explode with the 5G onset of short-range, high communication technology. So we're only at the starting point. And this idea of data exploration and understanding is really just, we're only still at baby steps. Watch what happens in the next 10 years.
Yeah, I absolutely agree. It's, so in the most, I guess, layman's recap of that, the data scientist, a few years ago, when I was working in banking, I'd go to these events, and there was a lot of question about what is the role of the data scientist, and and what kind of be it academic or applied experience should they have in being able to. But I guess you hit the nail on the head. If you've got computational / mathematical kind of competencies, and you have real interest in looking at magnitudes of data and being able to derive insights using formulas, equations, and algorithms, that's one of the key kind of factors of what we look upon in data scientists. And to add to that, there is a lot of synergy between what a data scientist and a technologist is, but we in our organization separate them, mainly because technologists use very tried and tested techniques that are in our world regulated and industrialized. So in infrastructure and distribution and communication services and so on and so forth. Whereas our data scientists, in a lot of cases, we just get data. We don't know what we're doing. We don't know what we're looking for sometimes. So we kind of ring fence them into this lab situation where we're like, you guys are actually scientists. You've got to go in there and you just got to play around. And when these insights come about, or when we understand what problems we want to solve, as a result of them solving these solutions, then we industrialize it into a technology stack which can be commercialized. I mean, and to lead on from that, Kate, perhaps you could talk a little bit about the actual technology that you use as a data scientist to help you in your day-to-day kind of job, and you know, yeah.
Sure, yeah. Yeah, so I think nowadays, I think the majority of data scientists, the primary kind of programming language that's used would be Python. So that's what I kind of use every day. It's what I spend most of my time doing, is coding in Python. And there's a lot of different libraries, they're called, or packages that you can kind of add on top of Python. There's a lot of specialized libraries just for data science, AI, machine learning, that kind of anybody that's familiar with data science they'll know about these packages and how to use them. So there's a bit of a barrier to entry, I guess. Yeah, pandas, NumPy, yeah, as Harold has mentioned. These are kind of the common ones, like scikit-learn, TensorFlow as well, which kind of, if you're not familiar with them, they sound like just, you know, like buzzwords basically. But kind of, if you have a knowledge of data science, you'll come across these libraries and you'll learn how to use them. There's also, if you're using your own data, then you're going to need to obviously store it somewhere in a database. And I think like Google, Amazon, they offer their own database services. They also offer their own kind of data science and AI related tools nowadays. There's a lot of different platforms that offer more kind of ready-made AI and data science related tools. So you don't necessarily need to be building your own data science and AI like right from the ground up. There's these kind of ready-made platforms available that can kind of help you get there if that's what you want. Also, obviously, Emerge IQ, we work with companies to kind of bring their data science and AI related kind of needs to reality. So yeah, that's more or less it, I think.
Yeah, yeah, I'm seeing people send through some other stuff such as Linux and R and SQL. Yeah, you know, for an organization so some of the organizations we work with, they have literally, you know, a lot of them are startups. So, and they have an idea, which then they come to us to say, look, can you help us, you know, add a layer of AI or data science to what their existing offering is or what they do. So they haven't got in any way a clue about what, you know, or how to implement data science and AI. And that's the vast majority of SME organizations fall into that kind of that realm of lack of knowledge. And you know, to echo Kate's point, you know, the individual who is that expert is that expert. It doesn't matter whether they're in-house within an organization or whether they're, you know, in you know, a data science as a service organization as well. But they use the same tools, right? And it's no different than having a general developer, you know, a developer who develops a website, or you know, an infrastructure guy who hosts websites or servers and things like that. Everyone has core competencies that accompany that kind of role. It's up to the organization to make sure that they have the correct resources and competencies around them so that they can deliver the end product with the best of the capacity and dollar value that they can get out of it. Which is why we've hit we feel a very sweet spot, because a lot of organizations, rather than hire an internal you know, one head data scientist who has to be, you know, they're quite excellent people, you know, and in some cases for them to partner with an external organization makes more sense, because that organization has the entirety of you know, 6 or 7 data scientists, which is a lot, still actually more economical for them to use organizations rather than hire in-house. Okay, so
there's one. Yeah. Sorry, there's one point I'd like to add that brings all this together. And if you only listen to one thing I've said on this call, it's this: the key thing is that it's never been easier for anyone to grab some data, which can be a pain in itself, structuring everything, but get some data, throw it in a myriad of open source libraries, they're all freely out there, and produce some results. The one key thing area where expertise is really required is, how do I know I'm not overfitting? I'm trying to squeeze too much out of that data than is actually in there, because it's all very well having masses and masses of data, but you can find patterns in, if you throw together enough random numbers, you will find a pattern in that's spurious. It's not going to actually solve your problem when it comes to deploy it in the real world, which kind of relates to a question in the chat about the self-driving cars and why that's such a difficult problem. But the key thing that a data science expertise brings is really understanding the strengths and weaknesses of the models, which ones are suitable, how to train them, and how to guard against that overfitting, which can be really damaging.
I think that nicely segues us into the next part of the session, actually. Let's look at some of the questions that are coming through the chat. Right at the top, we see, what is unsupervised data? So, I'll throw this your way, Hayne, being an educator in the area. Unsupervised versus supervised, that's more jargon for people to understand around training models. Yeah,
I think, correct me if I'm wrong, I think it was Dev Aditya. Hi Dev. I think perhaps it's more with the questions leading towards what is unsupervised learning, in terms of the question. So first of all, before I talk about unsupervised learning, I need to talk about what's supervised learning. Right.
If anyone who is we're answering the question to, feel free to unmute yourself and have a dialogue.
Yes. Yeah. Just jump in.
Kind of open now.
so what is supervised learning first? Supervised learning is one of the paradigms that is used in machine learning. But let me go back another step. What is machine learning? So machine learning is a subset of AI in general, and it's a very big and powerful one. It's one that is used in lots and lots of things. And why is it used in lots and lots of things? Because, as I said earlier, because people have a lot of data. Now, what is machine learning? As the name suggests, it's different techniques, and there are dozens and dozens of different techniques that it basically creates models and solutions by example. So that's supervised machine learning. So it's by examples. So that it rather than explicitly setting out a set of rules or explicitly setting out a recipe and saying here's the formula before you even look at any data, you have a sort of a setup that has, as Chris said earlier, that has all the sort of knobs and dials set at sort of different values, and then you start to give it different examples of one after another of things you're interested in. It could be pictures, it could be a data, it could be a medical report, it could be some words, some text, it could be anything. It could be anything that is deemed as data. And you give it lots and lots of examples, or the pictures of the fibers that Kate said earlier, and then say, okay, here's an example of this, and here's an example of that. And that's if you give it enough examples and choose the right learning framework and choose the right methods for learning, eventually the model will learn, or converge, as jargon goes, converge into a point where it starts to get enough right that satisfies you. So first of all, it'll just be wrong all the time, half the time, and then it starts to get more and more right as you go, as these bells and whistles are dialed into a more correct setting. And then you stop at a point where you're happy with its accuracy and how well that's being able to give you the right decision or the right output of your model. So that's showing by example is supervised learning. That's where the term supervised means, is showing the example of this is an example of that, this is an example of that, and this thing is an example of that other thing. And you supervise the initial learning process by giving examples that you know about already, that you already know about. So that's supervised learning. I hope that's clear enough. Now, the other type of learning is unsupervised learning. So unsupervised learning is when you have data, you have lots of data, but you don't really know what sort of category or what sort of thing that bit of data represents. You don't know beforehand what sort of output you want to assign to that particular data. It could, again, an image, it could be text, it could be whatever. But you still want to analyze it. You still want to learn from it. So how do you learn? How do you teach a model using data that you don't have prior examples to give it that you know about already? So that's a curious question. That's a curious point, right? So this idea of unsupervised learning came about. And unsupervised learning is quite powerful because quite often you don't have prior examples of what you want. So unsupervised learning are different techniques that basically don't need those prior, what we call labeled examples of the data that you care about, but you have the data, but you don't know exactly which way it goes. So so what these methods tend to do sometimes is they tend to have algorithms and techniques that allow the data to sort of self-arrange and self-regulate and sort of partition themselves based on various other things, like how similar is that bunch to each other, how similar is this bunch to each other, and can we allow them to sort of separate out by perhaps as an example similarity. So well, this we don't really know. I'll give you some examples. Let's say you have pictures of fruit, a tropical fruit that you don't know what they are because you're not the tropical fruit expert, right? So let's say you have piles of pictures of tropical fruit, but you don't know exactly what that is, or you don't know quite exactly what that tropical fruit is. But you have these pictures and you want to do something with these pictures. And then you might want to say, okay, let's have an algorithm that looks at color and shape and a few other things that characterize different fruits. And will the pile of different tropical fruits emerge where you end up with a pile that's sort of reddish and round, and maybe another one that's greenish and elongated or something? And then have I then learned without explicit supervision how to categorize two different types of fruit? Okay, so that's how one might think of how to do unsupervised learning. So it's a different paradigm to supervised learning where you don't have the examples at hand, but still, even then, you can still have methods that learn from the data you have, but in a way, various tricks and methods that do that, and then you still get something out of it. You might end up having a model that understands these two different types of fruits without you even having the prior knowledge. So that's my quick 5-minute attempt at teaching unsupervised learning. I hope that made some sense there, Dev.
Yeah, thank you for that. I just had one question. So when you were talking about the fruits as well, you talked about the colors and the odd shapes. So it's very superficial in that manner. It's very light, so it's obviously not deep in terms of what we're defining. But do you have to even give that level of input for the unsupervised to kick in, or not?
So that's a good question. So this actually leads on to another buzz term that you might hear quite often these days. It's a buzz term called deep learning. Now, the example I gave that about, if you already know to give it the roundness or the color or the shape, some other what we call feature of the data. So we know that, well, we want to look at these sorts of attributes of that fruit. And we use that to train the unsupervised model or perhaps the supervised model. But we have to give it things to measure. We have to give it some measurable things to learn off, to learn from. But in the traditional older methods that go back further in time, we had the data scientists and the computer scientists had to sort of pre-assign, as you mentioned, Dev, what sort of feature that might be useful. And that doesn't necessarily come from computer science. That could come from, in my example, agricultural knowledge or something, some other area. and they know to that, you know, these are the things that separate that sort of fruit from that sort of fruit, is the roundness, let's say. So these are discriminatory features, is what we call. Now, the next step change in AI that happened somewhat recently in comparison to a lot of the other methods is this paradigm called deep learning. And deep learning, you know, again, it's sort of trying to unpack this a bit, has the ability, especially with things like images dev, where you don't necessarily have to have this prior knowledge to feed the supervised or unsupervised learning model, but because you just give it the almost raw image, so you're not even telling what discriminatory features it ought to have. You just say, here's an image here, and here's another image there, and that's it. And then you just, you know, you're sort of done with that. And then it has the capacity. That's what if you study this in the deep layer of the neural network has the capacity to learn the feature. It's called feature learning. Mm-hmm. And that's hugely important because not you know, as you point out, you know, we have good algorithms that are good at optimizing the bells, you know, the dials and knobs for the parameters, but we still are stuck with, well, if it's not given the right information in the first place, rubbish in, rubbish out, right? Yes. It still won't learn anything if it's just given useless information, if it's given useless features. So this deep learning technology, it started out in imagery in the beginning. It had its most initial success with images and pictures. Now expands to other things, can learn features from within a particular data point, and what we mean by data point here is a picture, right? And it can learn that. So we're increasingly having all of these learning points automated by different techniques. There are still things to give the deep learning model priori, but further and further, you need less and less. You need to be less and less lucky in the beginning, let's say, to have that working.
I want to add something on that to just demystify a bit, because so what Haynes described is like originally you used to have simple linear models, for example, but you put in, you manually construct non-linear functions of the data that you know are very informative. So to take the computer vision example, you might actually say, well, look for circles in the image, look for edges. These are things that then go into a simple model and it can do something with them because you've given it a head start. The idea of deep learning is to spare you all that, spare you the human experts, and just let the model figure this all out. In order to do that, all it is it's just capturing non-linearity. If you have a single neural network layer, it can be a very simple linear function of the inputs. The more you stack together, the more mathematically expressive it becomes. So there's no real magic there. It's just that you've made a more complex mathematical expression that can capture mathematical quantities, you know, quadratic terms, higher order terms that the simpler models just architecturally aren't able to do. And that's all it is. That's why it can naturally learn these features if you're lucky, because it just has that higher degree of mathematical sophistication.
Yeah, I'm going to jump in there, and just for the Homer Simpsons like me on the call, even though I'm CTO, you know, it's as simple as being able to just point and push, right? You set this up in such a way that once, as a result, you're running the data through it, you will then hopefully reap the reward of seeing some, you know, you've got enough data for it to establish itself and understand and learn for itself, rather than, as Hayne was alluding to before, having a whole supervised process. Correct me if I'm wrong, if that's the most simplistic kind of way of putting it. I'm sorry, Chris, I interrupted there. Is there anything else that you want to add?
No, I mean, I guess it just got me thinking that there was a AI winter for neural nets. They originally popularized years ago, and they were just trying to pile these up to get these very effects in. And I mean, deep learning, to my mind, it's a bit of a marketing term that was, you know, Geoffrey Hinton, God bless him for kicking all this off. Yeah, he's been working on neural networks for decades, but it just sort of hit a point where they were finally throwing enough data and enough computing power at these approaches that had failed before, just because for those reasons. And actually, anecdotally, some people before, they think actually they had some just coding errors in the stuff that meant these things didn't converge. The real driver of the AI revolution is these so-called auto differentiation frameworks, to get technical. TensorFlow, PyTorch, they just enable you to write the craziest model, and they handle how to calibrate it and train it for you. And that's very different to how things were even a few years ago. Which
echoes the now importance of the software that we're using, and the capabilities of also the hardware. When Hein was talking about, look, this is just the beginning. 5G is about to take effect. We're going to be we're doing some projects, a music project, for example, which is real time, and relying on 5G because we want that connectivity and to capture data and significant amounts of it, so that you can actually, and we now have the processing power, coupled with the data science kind of software and stuff such as TensorFlow that can really, expedite, outputs rather than before, when it was all, a lot more rudimentary. Moving on to the next question then, from Rahman Abdullah, how can we get good data for research purposes?
Actually, there's a self-driving car question before that.
Oh, sorry, was there? Sorry, okay.
Yeah.
Let's just start. It's back. Okay, self-driving. Then, Hein, I'm gonna chuck back to you, and then.
Okay, I'll try and be quick because I'm conscious of the time. Why are they not on the market? Well, putting aside the legal and other sort of societal questions that need to be resolved first, things like who's responsible for a crash and things like that, but sticking just to the AI and the technical side of things, in self-driving car research, my understanding, and I'm not expert myself, but in my understanding that there are 5 levels, and the 5th level being a completely automated car that literally has no input from a human being whatsoever. And level 1, 2, and 3, 4 are sort of different levels of human need to be present to maybe step in and correct things or have some input in that. So there is a company in the UK, company called 5AI that's sort of set out to find level 5. Now I think that in terms of just engineering terms, technology-wise, I don't think they've reached level 5 properly yet. There are various reasons for that. And they are still, in a sense, there might be some sort of some autopilot style cars that are out there now, but I think there are still some technical things to resolve, further to the societal things to resolve, like legal, liability and various other ethical questions, I guess. So there's a whole host of reasons, but my answer to that is. There's lots of reasons why it's not in the market yet, but it's getting there, and it probably, I wouldn't be surprised if it gets there soon.
Out in California, they're testing this. A number of companies, and they're testing fleet transportation using automated trucks.
Yes.
So they're dedicating lanes so that
the trucks that drive very close to each other, that because to fit more trucks, because human can't do that.
Yes, the humans are still, of course, in the trucks, but they are now using, they're dedicating lanes so that they can test this. This is mainly in America, but they're seeing results of, these transportation companies being able to just send fleets automatically across, various parts of the country, and hopefully, I guess it's not if, it's a when kind of question as far as I'm concerned. When are we really going to have this up and running?
One reason it's so hard is because of, as far as the models are concerned, unknown unknowns. I mean, models, until we have general full-on AI in the way the term originally used to be used, where computers can think, they can rationalize about things they haven't seen, they can use concepts they've learned in one area to inform decisions in something that's new, that's proper AI. How does a car deal with, something that it hasn't seen in training? A tree has suddenly collapsed and fallen in its path, for example, or, all these freak events. It's not going to know what the hell any of these things mean. In fact, they can even get confused just from their, LiDAR and visual sensors by weather conditions or things. occlusions of road signs. It's really, really hard because they don't see, these things don't see the world the way we do. Ironically, given coming from someone who can't drive anyway, but it's to cover all these eventualities is nightmarish, and that's why these companies are spending such a fortune on research.
I hope that answers your question in some way or another. Moving on to the next one for Kate, from Raman, how can we get good data for research purposes? And I think Kate's actually the best person here because she does a whole load of research for us, which hopefully goes into the applied space.
Yeah, so I think the important thing to remember with any kind of data science, AI, machine learning that you do is the quality of your model and the outputs you get are really, really highly dependent on the quality of the data that you put into the model. So it's almost kind of the most important part is getting that good quality data to begin with. And it kind of depends on what kind of data you're even working with, but you kind of have to treat it almost like a scientific experiment, basically. You just go through these kind of controlled trials. You want to kind of get the purest, most kind of representative data possible of kind of whatever it is that you're looking at. Say, like, if you're trying to study like the weather, you'd want to kind of control the way that you get your data so that you kind of limit all the kind of confounding factors and the extraneous variables that kind of might influence your data. You kind of want to just make sure that you're getting the best possible quality data. I'm not really sure if maybe Hayne has some better ideas on how you can ensure that you're getting that good quality data.
I might jump in with some of the projects that we've been working on because we've had problems getting the data, and because in fact, I'd say most of our projects are somewhat cutting edge. The data is unavailable. I mean, Kate has written a dance detection AI, which we hope is going to be kind of integrated into a number of different areas, in the music industry. But there is no data to measure people's dancing. So in that case, we just had to go out and do it ourselves. So we've developed a test app, which we then give to our, an audience of users, and we're in the process of capturing that. And then we end up having to actually gather that data ourselves. And then on the other side, it's when we work with other clients, we know we do an investigative process of finding out where good data can be. And we try to garner the support or the kind of the backing of where the company who has potentially that data. With the project that Kate was talking about before, the Fiber IQ one, we've been engaging with the authorities of in the UK, the Health and Safety Executive of Great Britain, to see whether because they are the regulators of this health and safety industry, to see whether we can use their data. So I guess there's no right or wrong answer. There is, as Kate was saying, you have to treat this like an experiment. You're going to have to go out and find, the best channels of good data that you can get. We do use, we use public sources of data. The Department of National Statistics, we get loads of stuff from those guys for one of the solutions that we did for payments. And then other sources like Kaggle, which is a great, and I don't know, Hayne, Chris, Kate, if there's any other kind of sources which are available. GitHub's got lots of stuff.
It really depends. Lots of stuff in the public domain, Kaggle, universities providing it, GitLab. But for the more unusual stuff, you might have to be prepared to go out and get it yourself, as Ms. has said.
Yeah, and the other thing I would like to just end on with that is, yes, it's very important that that you get the right high quality data set when you're doing your first experiments for research. But for the people who are not just doing research, but perhaps want to use this in the quote unquote the real world. Remember, the real world data is messy, it's chaotic, it's not ideal, it has bits missing, it's noisy, and it's got all sorts of things, errors and things in it. And whatever you make, whatever you create in terms of machine learning or AI modeling, it should not be too reliant on super clean data that is unrealistic. So it has to be robust to the messiness of the real world, and that's another area where we can advise on as well. That's another point that is not necessarily taught that comes from experience in doing these things, and it's not necessarily taught in textbooks.
I'm just going to jump in there, guys. There are a few more questions. If everyone's willing to stay on for just an extra 5 minutes, please do. Otherwise, feel free to drop. We were, we started to. We'll run over a bit. I think it's worth us just trying to close out the rest of the questions, if that's okay. But for those of you who do have a hard stop, thank you very much for your time. Please feel free to reach out to us if you have any questions. You can go to our website, emergeiq.com, and there's contacts there, and we are pretty good. We've got dedicated people who do go back to people within a very short space of time with their inquiries. And please do come through to the other sessions which are planned every month for the next few months. So moving on to the other question. Okay, following Yassine's question. Oh, hold on, is that the right one? Does the Internet of Things? So does the internet be defined as part of AI? Anyone?
As I say, well, there you go. That's a great data source. I mean, IoT is fundamentally about extracting, to Haynes' point about structured data versus it's like we're swimming in data without even realizing it. IoT is really just about grabbing that. I think what you do with it AI wise is up to you. It's kind of part of technology and innovation and the way things are headed. But I wouldn't necessarily. It's an application of AI, I would think.
Yeah.
Similarly, RPA, robotic process automation. If the little red devil's coming up on my side here, rather than the little angel, I'm going to say this is just people trying to make themselves sound like experts by coming up with new guff-worthy terms. But I don't know exactly what RPA is or why we need another term in this field.
There's a dev put a point in there saying that Google's just launched a dataset search in beta, so that potentially is going to be a great source of stuff. From Caldip, hello Caldip, sir, one of our friends and family. When do you think AI machines will be able to respond to human emotions and behavior? Now, this is actually, I'm going to give this straight to Hayne because this is actually his absolute expertise. We are developing an AI for wellness and human emotion, and in fact, we're doing a load of stuff in that kind of area. So, Hayne, perhaps.
So to answer the question of when, we can already do it.
Yeah.
So but what do I mean by that? Well, obviously, a computer does not have its own emotions and feelings. I mean, that's of course, that's needless to say. But what it can do is in this area, research is called affective computing, AFF, the psychological term affect, is that in the way that I can sense somebody's expression, whether the tone of voice that they have, or the body language, or maybe the face expression, or some other emotional expressivity, as a human to human, I can sense. I don't know for sure exactly, they might be a good actor. I don't know for sure internally what they're feeling, but I can get a proxy sense of what they're feeling through their expression. And really those expressions you can use sensors to pick that up. Obviously you can do tracking of the face nowadays. You can get somebody's heart rate with a sensor. You can get body language through different motion or capture tracking. And these sensors can now be used, not just to learn what somebody is saying, like, Siri, I want some pizza. It can also sense how you're saying it. You might be able to say, Siri, I want some pizza in a very angry way. Or you can say, Siri, I want some pizza in a very happy way. And that's different. That's an intonation of your voice. So it's the computing is also learning what's called behavioral cues from people. That's through experimentation of not so much the what is happening, but how it's happening. You could be walking, but you could be walking with a angry stride, or you could be walking with a sort of a happy springier step, right? So so these are these subtle things that are manifest through human emotion, and essentially in some of these more, it's not really out in the in commercial sectors quite yet, but it's coming. And that's but when do you think we can do it? At least in the research domain, we've been doing it for 10 years.
Yeah, and we're applying it. So
And Emerge IQ are doing it too. Yeah.
So at Emerge IQ, we've got a few problems where in the coming months we're going to be launching. You know, I mentioned the dance detector. Training a model to know when people are dancing, that is human behavior, that you're changing from walking to dancing. There's a distinct difference, and there's a whole slew of other kind of behaviors that we can really detect.
Thank you.
So there's a point, and thanks, Claudette. There's another question that's come in. Alistair pointed out that the FinTech Sandbox gives some good data, by the way. And Yassine's got another question. Do you think AI will one day make robots have their own consciousness? So that's the singularity kind of question. Perhaps we can finish on that. And I'll open that to anyone. In fact, all three of you, what are your views on what robots having their own consciousness?
I think Dev wanted to do a voice question, please, just before that.
Oh, yeah, sorry. Okay, let's just jump back to Dev. Do you want to jump in with your question, sir?
Yeah, thanks. Thanks a lot. I'll just pop into what Haynes said before this. And the main thing is you're talking about the whole adaptive point and using cameras and other sensors to really feel that gut feeling that human beings feel. Is it too far of a stretch to start exploring or looking at things like mobile EEG as well? And I'm specifically asking this from an AI and neuroeducation marriage.
Sorry, did you say mobile EEG?
Yeah.
There's a real problem with EEG. It's a very weak, very, very noisy signal. I mean, I think Zuckerberg's got people looking at this and other guys do, but I think that they've actually been playing with actual implants in the head. It's a very, for that reason, once you get through the bone and the skin, it's a very, it becomes a very tricky thing to capture. So when you say, a lot of these headsets require...
Can we just, for everyone on the call...
Oh, yeah. So electro and the one when you have little pads on your head trying to pick up your brain waves, that it's basically that. I mean, there's lots of research going on into can we look at people's emotional state via EEG, but it's a very noisy, very low resolution instrument. Most of the studies that are showing interesting results are based on invasive techniques for actually probing the brain. So yeah, I wouldn't expect to see those soon for those kind of more scientific reasons.
Yep. And very quickly also to add to that, rather than the sort of the internal psychological part of the brain, there are companies that have created these sort of very easy fit, I forget the name of the company, helmet that you can put on. You have to put douse a little bit of water on it and put it on. You can move it, you can walk around with it. But with that, the key, it's still limited to things like thinking left, thinking right, or thinking up. It's very basic. You can train, it's using machine learning to train the signals that when you're thinking left, it knows that you're thinking left based on that pattern of brain signal, or when so it's very, very coarse outcomes. But the idea behind that is somebody's completely paralyzed and they can't move, they can still think particular basic outputs that if trained well enough based on their particular head, then it can still have some meaningful recognition output. But as Chris alluded to, as soon as you shift slightly, or it's one of the probes are not working, it's all gone because it's too fragile.
Dev, I think feel free to reach out to us. Mizan at Emerge IQ, if you want to just send us an email, and we can continue this dialogue, because that is actually Haynes' specialist area when it comes to sensory behavioral kind of AI.
I'll just connect with you guys on LinkedIn. Thank you for that.
Okay, cool.
Yeah.
And, okay, and then I guess just to close off, all three of you very quickly, do you think AI will one day make robots have their own consciousness?
I think. Oh, sorry. Go on, Kate, hogging the camera.
Yeah, well, I think sometime in the future, I think it will definitely happen. But I think with the technology we have nowadays, it's not like if you keep adding layers to a deep neural network, it's not going to suddenly become sentient and gain consciousness. I think it's a whole different kind of AI that we're going to need to actually bridge that gap. So I think we're still quite a ways off from that, and I kind of, it's cool to think that I prefer to kind of stay in reality and what's present, like what we can do now and in the near future. I kind of prefer to think about that personally.
Chris?
I think we'll have two kinds of AI. One will have this sort of human kind of consciousness, developed by actually mirroring the development of a person from, you know, the fetus to where we are now. I think that's one approach, and I think there'll be a different approach that will produce a very different kind of intelligence. I think we'll get to human level intelligence first, simply from the fact that we as a species appear to be getting a lot stupider.
I'm not going to deny that one. And Hayne, just to finish off.
All right. Well, I'm going to veer off slightly because there's great answers from Kate and Chris in terms of the current technology, but I want to sort of perhaps talk about it at a more philosophical level. When you say consciousness, I would imagine that you mean this type of sentience and consciousness that you know, animals, at least animals, or humans definitely, some higher order animals have, right? And that sort of sense of awareness of the world. If we think, now it depends on what, I guess, treading on thin ice here. If we think that as we look at ourselves as machines, as an entity, that we have cells, we have a brain, a skull, and this setup as us has as we are exist as human beings, we have consciousness, and we don't need anything else further outside of what we are in order to have this consciousness. I.e., there is no ghost in the shell. There is no. If we assume that there is nothing other supernatural that is affecting us to have this consciousness, if we assume that. And if we as entities can have consciousness, then in the far, far future, and I say far, far future, I can't say far enough times, I don't see in principle why artificial consciousness cannot also be recreated in principle in the very far future if we don't need anything further than wetware or software or hardware, whatever it is that we are going to use in that far future. So in principle, I would say, yes, maybe one day, but not by anything we're doing right now.
Okay. Well, you know, I'm not going to go into my views there, but I guess that closes off the session for today. Apologies for running over everyone. I guess that's the hazard of these situations. There's a lot of questions and a lot of input. So thank you very much, everyone, for coming through with questions. It kind of rounds off the whole session really well. We are going to have the follow-up session, which is next month. So please go onto Eventbrite or the Meetup and sign up for the next one. We are over the next 3 series. In the last one, we hope that we'll actually be able to do a kind of transformational workshop during the hour, so that everyone, you know, companies or anyone who's interested in actually, you know, having a data science and AI strategy, you'll be able to, at the end of that session, have, you know, a one-pager or some sort of indication of the steps that you'd have to take as an organization to really, you know, get your teeth into using data science and artificial intelligence. So I put an email on the chat. There's a link to the next webinar to register. Thank you very much, everyone, for your attendance. Kate, Hayne, and Chris, also my humble thanks for you making the time to join us today, and you know, hopefully demystify something which is still you know, on the tip of everyone's tongues, and still an area where, you know, the entire world, when it comes to organizations and industries, are still, you know, significantly behind, and in the next 10 years we're going to see, you know, real change, you know, using data science and artificial intelligence. Okay, thank you very much, everyone. All the best.
Thank you.
Yes, thanks.
Right. Thanks.